Hello everyone, this is Ali Lab for Oscillation, the final lab. The objective of the lab is to observe the motion of oscillating spring, which is a real-life model, and compare that with a computer model. Fundamental principles and formulas that I've used throughout the lab. First is Newton's second law, or the momentum principle. I found it used to find two important data, which are the final velocity and the final position inside of the loop, and the energy principle, which is the change in energy equals the change in kinetic energy plus the change in gravitational potential energy plus the change in spring potential energy. And here are the formulas for each one of them. Last three formulas is the net force, so it's equals to F gravity and Fs. There's only two forces. This is a screenshot from the tracker app where I got all my data. So for the coding, the first one here, the lab 44, I got it from the lab 4 instructions. I went to the video, which is 0.402. This is the mass of the ball. Line 47, this is the position of the ball, which I got it from the tracker app. At line 78, I had to first find T, the oscillation period. So I got 4 oscillations and divide that, 4 oscillations from the tracker app and divide that by 4. And here I use this equation T equals 2 pi times the square root of m over k, and I solved for k and got the value of 7.224. At line 81, to find L naught, we have to assume first that the ball is at equilibrium. So the force of gravity equals the force of spring, and I solved here for this equation for L naught and got the value of 0.15465. From line 84 to 86, the goal is to find S. And at line 89 to 92, these are the formulas that I've already mentioned about the energy and the introduction. So now we're inside the loop. Initially, I initiated that each energy is equal to the energy, the Ki, so equals to the K that I've calculated for the loop, and so on for each one of them. At line 110, I found the force of gravity, and 113 found the force of spring. The goal was to find the net force at line 116. So after finding the net force, I can find the new velocity and new position from the momentum principle. And at line 125 to 127, the goal again to find the new S. Fourth coding slide, here is I just found the difference between the new S, the new energy, and the initial energy from each one of them. Now I have two graphs that are the results. First one on the left, you can see the predicted is from the glow script is in blue, and the observed is in red. You can see it's quite similar in some places, for instance here, and here, but it's not perfectly aligned. For instance here and here, and some reason, one reason for that is because we did not include drag force. Also, the reason for these big jumps is I might not click perfectly on the object using tracker app. And the graph on the right, the change in energy versus time, I've labeled each energy. So the blue one is the change in kinetic energy, the green one is the change in spring potential energy, the red one is the change in gravitational potential energy, and the yellow one is the change in energy, which is equals to 0. And the conclusion, so I have to answer 2 questions for your model system. Is the energy principle satisfied? The answer for that is yes. As you can see, the change in energy is equal to 0, which means that there is no forces affecting the system from the surrounding, which satisfied the energy principle. The second question, you had to compare two oscillation period for X and Y in the tracker app. So as you can see that X is longer than the Y, and the reason for that, there are more forces at the Y direction. Thank you.